Hello everyone, so I'm solving this medium level problem called remove zero sum consecutive nodes from linked list. It's a good problem. I did it as a part of daily problem. I'm trying to solve that. So let's take a look at what this question is asking us to do. So given the head of linked list, we repeatedly delete consecutive sequences of node that sums to zero until there are no such sequences. After doing so, return the head of the final linked list. You may return any such answer. Okay. And then it says note that in the example below all sequences are serialization of list node objects. So basically this head is telling us that this is the linked list. We have 1, 2, negative 3, 3, 1, right? So in this question, it's asking us that if you find the consecutive sequence of node that sums to 0, we just have to delete those, right? So let's consider this first example. So if you actually think about it, this is very similar to a already existing LeetCode problem called prefix sum. So if you guys don't know what exactly a prefix sum is, let me just describe real quickly. Let's not take linked list. Let's just assume that this is the given array. So a prefix sum is a running sum on that particular index. So if I say what's the prefix sum of this entire array, we are just gonna start off with the first element, so 1 over here. Then we'll move on to the next one and we'll keep the track of the sum. So we just encountered 1 before that, so I'll just add 1 to this 2, so it's going to become 3. So up till this point we have 3, the sum is 3. Now let's move on to the next element. Next element is, or next number in the vector or array is negative 3. We already have seen the running sum is 3 over here at this point, and then we move on to the next one, so it becomes 3, negative 3, so it becomes 0 over here. And then again the running sum is 0 at this point. We'll move on to the next one, we'll see 3, so 0 plus 3 is 3. Then we will move on to the next one where 3 plus 1 is 4, so that's the prefix. So we have to use very similar logic over here as well. As soon as the running sum or a prefix sum is equals to 0, we are going to delete those nodes from this linked list, right? So let's start over again, keeping prefix sum in mind. So the prefix sum at this point is just 1. We'll add 2 to it, so it's 3. Then we'll move on to the next one. So 3 negative 3 is 0. So now we know that we have encountered 0. So the running or as it says, consecutive sequence of nodes is 0. So we have already encountered 1 plus 2 is 3, 3 negative 3 is 0. So at this point it's 0, right? So we'll just remove these elements. What is it left? We just have 3 and 1. So that's why the answer is just 3 and 1, right? And then it says answer 1 to 1 is also accepted. 1 to 1. Okay, yeah. 1 to 1 is just take this window. In this window, the prefix sum is 0, right? So let me discuss what strategy I'm going to use over here. So since for prefix sum, I'll be using 2 pointer essentially. The reason I use 2 pointer or just keep track of 2 indices, so that as I move forward, I'll just keep track of the window or the running sum of that window. That over here, this window has 0, so I'm just going to keep track of this, or as I told initially, that the sum of this first three element of array, whatever you want to say. Over here it's linked list, so the first 3 nodes of the linked list sums to 0. That's why either it's 3 1 or 1 to 1 is also accepted solution. Okay, let's move on to the second example. Over here let's do the same thing over here. The first element is 1, so let's take a running sum. So 1 plus 2, 3, 3 plus 3, 6, 6 negative 3 is 3, and 3 plus 4 is 7, right? So in this window, starting from this till the end, we haven't encountered 0 yet. So what we are going to do is we are going to start with a smaller window now. Since we have already seen in this bigger window we did not find any 0, let's move on to the smaller window. So let's consider starting from 2. So 2 plus 3 is 6, or 2 plus 3 is 5, 5 minus 3 is 2, and 2 plus 4 is 6, right? So we did not really find 0 even in this window. So let's move on to the next element, and let's start off from 3 this time. So 3 negative 3 is 0. So we encountered 0 over here, right? So now if we remove these 2 elements, what we are left with? We are just left with 1, 2 and 4, and that's the answer. Okay, let's try our algorithm on the third one as well. Let's start off from the first element over here. It's 1, so the running sum over here is like until this index is 1. Then we move on to the next one. So 1 plus 2 is 3, 3 plus 3 is 6, 6 minus 3 is 3, 3 minus 2 is 1. So we haven't encountered 0 yet. So let's move on and now start from 2. So 2 plus 3 is 5, 5 minus 3 is 2, 2 minus 2 is 0, right? So now we have encountered 0. So we have to delete all of the elements which exist in this window. So the only element left is 1, right? So you will get the hang of the problem, right? Like as I explained, once you go and watch the video again, you will understand what I'm doing. What I'm doing is I'm starting off with the first node of the linked list. I'll keep on iterating in that linked list. As soon as I hit 0, I'm just going to delete the entire node which exists in that window. If not, I'll just start it from, or like make it even further shorter so that I can look in a smaller window, and I'll keep on doing it until the end of the node, right? So let me formally write what I'm trying to say over here. So let's start off with okay, so I'm going to use something called sentinel node. What this means is that essentially creating a dummy node so that I can keep track of my linked list. So let's create a sentinel node, which would be just creating a new node, list node star, and let's just call it as new head. So that's a new head, and we have to create a new linked list, a new node, which will start with 0, and the next element should be head. So that what's going on is that I'm just creating a new node. So just think of it as creating a new linked list where the heads or the new head starts with 0 and then it connects with this one. And now I'm gonna just iterate with the existing stuff or the new head. So let's just call it as new head. So now what I'm doing is I'm creating a I'm not creating exactly a new node. What I'm doing is I'm creating a reference to a list node or a pointer to a list node, which will which is referencing a new head, right? So it's this pointer called start is pointing at new head, right? So once we have that, what I'm gonna do is, okay, I'll write a while loop which will have a condition where start shouldn't be null. So keep on running it until it reaches the null pointer. And inside that, I'll create another pointer, as I told initially, right? I'll be using 2 pointer over here, or 2 pointer, just to keep track of the start of the window, and end is the end of the window. So it should point at start next, right? We're gonna point it to the next, because if I'm starting with 1, I don't want to start again like point the end at 1, right? Because then both of the pointer is at the same position. I don't want that. If start is at 1, the end should start with 2, so that we can have the running sum. So let's start with this, and also we need to have a variable which will keep track of our the sum. So let's just call it prefix sum and just initialize it 0. Once we have that, we'll have another while loop, which will another while loop is necessary because we are keeping track, like as I showed, right? In this example, if we just start from here and on 4, we don't get 0, so we need to again move on the second point, and same this end. What this nested for loop or while loop does is that it keeps on increasing the pointer to the next one. So this would be very similar to the previous while loop. But now this time it should iterate until it reaches a null pointer, right? And then we'll check, or then I'll just add the prefix sum first, or just update the prefix sum. It would be have the already existing prefix sum and the end value which exists in the end pointer, and then we'll check if prefix sum is equals to 0. That means we have come to arrived to a position where that window sums up to be 0, right? In this case, right over here. these cases where the window is 0. Now what we need to do is we need to delete. So for delete, there is this operation. For example, if the start is at 2, we'll know that start is 2 and end is -3. What we need to do is now join 2 with 4. So the only way to do is we need to point the start's next node to the end's next node. So that's gonna be the new connection, right? Start dot next, or start pointing next is end to the next. Oh, next, right? So once we arrive at this position at 2, just think of 2 being the start at the start pointer, and then what we need to do is we need to make this connection from 2 to 1. So start next and end is over here at 3, right? Because -3 and 3 is 0. So the end is over here. Then ends next, we need to connect starts next to the ends next. This is what we do. And since we are in this while loop, we also have to update the end. So end equals to end next, so that it traverses to the next one. So end next, and we have to do the same thing with the start over here. So start equals to start next. And once we have that, we will be returning new head next, because as you can remember, it's a sentinel node, right? It's a dummy node which I'm just using to keep track. So I'll be returning the dummy's next node, because that will head towards a new point towards a new head. So that should return new heads next. And that's the reason I was using a dummy node, so that I already have a track of where my new head would be. It would be new head next. Let's try to run this. Okay, so all the 3 cases gets passed. Let me submit it. All right, successfully submits. So again, let me give you a review quickly. So what we did is this is something which, if it's new to you, you might it would be helpful to understand why I'm using a sentinel node or dummy node, because I want to keep track. I don't want to lose, because start and end pointers are moving, they are traversing, so we don't really, how would you know that now what the new linked list would be, right? So we need to keep track, and this is the best way to go about it. Just create a dummy node and then point that dummy node's next node to the head, and then at the end we'll just return a new head next. So the only trick is while traversing, you need to keep track of start next and end next. This creating a new connection from 1 to 1, this 2 next should be ends next, right? Because end is over here at 3 and start is over here, so starts next is end next, and that's basically the main logic, that we need to create connection as soon as the prefix sum becomes 0. And the iteration is simple, right? Both the pointer start and end goes till the end of the linked list, and then as soon as we hit the end of the linked list, it just aborts, or it comes out of the while loop, and then we return the new linked list. Really nice question. So it will give you a good idea of how to create connections when you have to delete, and that's the benefit of using linked list, right? Linked list data structure is pretty good, because in constant time you can remove the elements from it. Yeah, so that's pretty much today's question. Let me know if you have any other doubts. I'll look at my comment section, so you guys can put any question you have in comment section, and then I'll take a look. All right, thanks a lot for watching the video. I'll see you in the next one.